So for section 6.5, we're going to be looking at some special factoring techniques. The good news is, if you already understand the rules for factoring, this isn't really anything, just kind of noticing some patterns. For instance, if I have something squared minus something squared, a squared minus b squared, okay? I can factor this by going, first, look at the a squared. What multiplies to make a squared? Well, how about a times a? Second, this is kind of the term at the end, what multiplies to make b squared? Well, b times b. But our third step is to check the middle, and there is no middle term here, right? So it's almost like there's a 0 in the middle. There's nothing in the middle. So whatever I do, I need these b's to multiply to make a negative b, and I need them to 0 out in the middle. So what that does is that one b must be positive, and the other one must be negative, so that when they multiply, they'll make a negative, and so when they combine, they'll 0 out. Like, okay, does it work? Let's check it. A times a times b, that would be minus ab. B times a plus ab, and b times negative b squared. Notice we have the a squared at the beginning, the minus b squared at the end, and a positive ab and a negative ab would 0 out. So I'm left with a squared minus b squared. So if I ever have a squared minus b squared, they call this a sum and difference. Basically, you can factor it to a times a, and a positive b, and a negative b. So let's practice that. X squared minus 49. Once again, don't check out your brain. Just look at this and go, okay, what would multiply to make x squared? Second, what would multiply to make 49? Well, 7 and 7. But to make it a negative 49, one would need to be positive, the other one would need to be and verify that that 7 and negative 7 would make a 0 in the middle. If you're not sure, you can always distribute this. You would get x squared minus 7x plus 7x minus 49. We would get what we started with. So that would be our answer. What if I just have letters? What's y squared minus m squared? Not cool. Well, it still follows the pattern. It is something squared minus something squared. So first, what multiplies to make y squared? Second, what multiplies to make the m squared? Well, one positive m and one negative m. Does it work? You can always check it out. Y squared minus my plus my minus m squared. The my's cancel out, and so we do end up with what we started with. How about z squared minus 9/16? You're like, really? Okay, well, think about it. Still follow the same process. First, what multiplies to make z squared? Second, what multiplies to make 9/16? Well, that's not too bad. The way fractions work is I'm looking at the top times the top. What times itself makes a 9 on the top? And on the bottom and the bottom, what multiplies to make a 16? So 3/4 and 3/4 would make 9/16. And to cancel out in the middle, one would need to be positive and the other one negative. See? Nothing to be scared about. How about x squared minus 8? Well, what multiplies to make x squared? Second, what multiplies to make that 8? 1 and 8, 2 and 4. But none of those put a 0 in the middle, do they? So this is not factorable. Or we say it's already simplified, but not factorable, I think would be the way I'd want that. This doesn't factor any further. It doesn't fit the pattern of something squared minus something squared. But even if you don't see that, you can check it out, and nothing makes that 0 in the middle. How about p squared plus 16? You're like, I got this one. A lot of people will tell me p times p. That makes sense. Second, 16. How about 4 and 4? But here the 16 is positive. So to multiply and make a positive 16, both these 4's would need to be positive. Does that work? Does that make a 0 in the middle? If I have a positive 4 and a positive 4, that would be p squared plus 4p plus 4p plus 16. That is not a 0, is it? Like, well, that's easy. Just make them both negative. Okay, it makes these both negative. Does negative 4 and negative 4 cancel out? No. You're like, well, the only way that it could cancel out is if one of these 4s was positive and the other one was negative. But then look, that wouldn't multiply to make a positive 16. Now that would multiply to make a negative 16. What does that mean? This is not factorable. In fact, that's something I would put in your notes, that if I have a squared plus b squared, not a squared minus b squared, that is factorable, but if I have a squared plus b squared, that will always be not factorable. So we'll leave that once we get to that point. Let's kick it up a notch, just a little bit. 9m squared minus 64. Is this something squared? Minus something squared. Is this a squared minus b squared? Think of it this way, right? What squared makes 9? What squared makes m squared? So 3m times 3m is 9m squared. That's our a. What times itself makes the 64? So it's plus 8 and minus 8. You're like, I don't know, does that even work? You can always check it. 9m squared minus 24 plus 24 minus 64. The middle this time zeroes out. How about 81 r to the 4th minus 16? I don't know. Think about it. Is there something squared that makes 81? Is there something squared, something times itself, that makes r to the 4th? Check that, right? 9r squared times itself gives us 81 r to the 4th. We have an a. What is our b? So we have two groups. 9r squared, and we have a plus 4 and a minus 4. Here's the problem. You type that in, you hit enter, it will say that this is incorrect. Well, I'm going to check it, and if you distributed it all out, it would turn back into that. You'd say, this computer is wrong, it made a mistake. No, it will say, look, there's something in here that's still factorable. This is still something squared, this is still something squared. Can we do a squared plus b squared? No. We said earlier that's not factorable. But look at the second group. That is a squared minus b squared. Is that factorable? Yes, it is. Then this can turn into two groups. What multiplies to make 9r squared? 3r and 3r. What multiplies to make the 4? A plus 2 and a minus 2. And the one that's not factorable, we bring down. So this is kind of a fun one because you did the regular a squared minus b squared, but you ended up with another a squared minus b squared that you had to factor. So be careful to check your answers and see if you can factor any further. This is not a squared minus b squared. Okay? And so I'm going to encourage you on these to kind of do this logical, and then we'll kind of get a form for this. But look, could you just do this logically? First, second, check. What they're wanting you to see is that this is an a squared, and this is a b squared. This is something squared, and this is something squared. So, what multiplies to make x squared? What multiplies to make 25? Well, there could be 1 and 25, or 5 and 5, but it's something squared. Wouldn't it be nice if it were just 5 and 5? Well, check it. Could 5 times 5 make 25? Yeah. Could it make a positive 10? Yeah, if they were both positive. So we're doing this logically, but basically, if I have something that is an a squared at the beginning, I believe this is actually a 2ab, then it will equal a plus b times a plus b, or a plus b squared. And if I have something that's a squared at the beginning and b squared at the end, but it's minus, this will become a minus b times a minus b, or a minus b squared. This is probably the one that I don't want you to memorize, okay? It really is a nice little trick, but you really just look for the patterns and still try to do this logically, because people that try to make this into a great magic trick, they end up applying this to everything and losing a lot of points. So let me show you what I mean. Is this something squared? Is this something squared? Then wouldn't it be great if this was one of our easy factors? Let's see. What squared makes 9m squared? What squared makes 16? But check, could I make a negative 24 out of those? Well, 3 times 4 is 12, and 3 times 4 is 12, but to make a negative 24, both those 4's would need to be, check it out. I get 9m squared minus 12m minus 12m plus 16. It works. I like the pattern. I definitely check it. If it has an a squared and a b squared at the beginning and b squared at the end, I always check the pattern, but also verify that it actually gives you the answer. Okay. The other option, and I'm not a huge fan of this, but I have had some people do this, is you could do AC factoring 9 times 16. 9 times 16 would be 144. I need two numbers that multiply to make 144, combine to make 24. How about 12 and 12? And so then you could split it, and then you could basically get to this answer anyway, 9m squared minus 12 minus 12. That gives me 3m minus 4. This one, factor out the 4, gives me 3m minus 4. So I end up with what? 3m minus 4 times 3m minus 4. That's a lot of work, but if you like AC factoring, you may like that better. But keep in mind, if there is a pattern, I would check it first. This one has a pattern. It's an a squared and a b squared. So wouldn't that be lovely if it factored nicely? What would multiply to make 25y squared? What would multiply to make 16? Don't just put this and circle it and move on. Check that that makes a 20. See, 5 times 4 is 20, and 5 times 4 is 20. This won't work, and here's why. This would give me 25y squared plus 20 plus 20 plus 16. That does not make that 20 in the middle. This didn't work. So you need to make sure you check these. If you're looking for a nice pattern, awesome, but go back and check and verify that you get the right answer. Okay? So what does that mean on this one? Well, what it really means in this situation is that this one will not be factorable. How would I verify that if I wanted to be 100% sure? You would have to do AC factoring. 25 times 16, oh my goodness, right? Would be 400. All the products of everything that multiplies to make 400. 3 doesn't go in, 4 does. 5 does. 6 does not, 7 does not, 8 does. 9 does not, 10 does. 11, 12, 13, 14, 15, 16, 17, 18, 19. Check them all. Do any of these make a 20? No 20 there, no 20 there, no 20 there, no 20 there. That's a 30. That's close. These would not make a 20. So that means it's not factorable. Okay? How about this one? Somebody's like, well, that's not an a squared and a b squared at the beginning and at the end. Okay. So just write not factorable, right? You have to remember your old tricks. Remember, we have to look and see, is there anything that factors out at the beginning? Are there any like terms? 12, 60, and 75. I know 12 is divisible by 2. That won't go into 75. 3, That goes into all three of them. 4, not so much. Let's try 3. That would leave us with a 4, a 20, and a 25. Okay, make sure I did that right. Okay, I'm feeling good about that. They also all have a z, so factor that out. And this should still have a z. Okay, so does this factor further? I'm not sure. It is a special one. It is an a squared and a b squared now, so we could check that. Don't forget to bring the 3z down. Okay, what multiplies to make 4z squared? Well, if this is going to be our special one, it's going to be 2z and 2z. What's going to multiply to make that 25? That would be a 5 and a 5. Will those both make a 20? Let's see. If they were both positive, that would give me 4z squared plus 10 plus 10 plus 25. There's our 20. This is factored completely. So all I did was add one step. Do not forget to factor out any like terms first. All right, one more type. These are terrifying. There will be in the homework. I might have one on the test. I'm going to count this as extra credit. This is something that you'll do more in the next course, but I do want to introduce it. A cubed minus b cubed. I've had some teachers, I've heard them refer to these as SOAP questions. SOAP meaning that the S is same, opposite, always positive. Okay, so if it's a cubed minus b cubed, when I go to the first group, that sign is the same, a minus b. The second one over here is positive, that is opposite. And the b squared at the end is always a positive. Same here. If it's a cubed plus b cubed, it is factorable. The first group is the same. The second sign is opposite. And the last is always positive. So SOAP questions. So the question is, do these actually work? I don't know, like you just put it on a paper and we do it, we assume it's true. We could check it. Does a minus b times a squared plus ab plus b squared turn back into a cubed minus b cubed? So let's see. A times a. I'm liking that. A times ab. How about a squared b? And a times b squared would be a b squared. Do the same thing with the negative b. Negative b times a squared would be negative a squared b. Negative b times ab would give me negative a b squared. And negative b times positive b, negative b to the third. Notice that everything in the middle, I have a positive and a negative, so that these zero out. These zero out, leaving me with, it works. SOAP works. It also works on the positives, and that weirds some people out because the positives don't work when it's a squared plus b squared, but they do on the cubes. We'll verify. A plus b, a squared minus ab plus b squared. How about a to the third minus a squared b plus a b squared. Now when I do the positive, watch what happens. B times a squared is plus a squared b. B times ab minus ab squared. And b times b squared plus b to the third. See, this is the key. That opposite, that if this is negative, this one has to be opposite. If it's positive, the other one's opposite, right? The reason that's important because with that being the opposite sign, that's what makes everything in the middle zero out. So that I'm left with just a cubed plus b cubed, okay? So if it's a minus, the first group is the same. The middle has to be opposite, so everything zeroes out. If it's a plus, the first group is the same. The middle is opposite, once again, so it all zeroes out. Let's apply this. Let's apply it, like I said, and then we'll be done with the notes. The last two examples here. is this something cubed minus something cubed? Is the question you have to ask. Well, 8p to the third, yes it is. Right? A, what times itself 3 times makes 8? Well, 8 is 2 times 2 times 2. So our A is going to be a 2 and a p. 2p times 2p times 2p would give us 8p to the third. Is 27 something cubed? Yes, it is. It is 3 times 3 times 3. So that makes our B a 3. So how do I handle this? Well, I go to my notes. My notes say that since I have A cubed minus B cubed, the first group will be A minus B. That makes our first group what? A minus B, or 2p minus 3. See that? Then what? Well, A squared, that's A squared, that's blue, not yellow. Why am I changing the colors? Sorry. A squared is going to be, what is 2p times 2p? Negative means the middle will be positive, AB. That is positive 2p times 3, so positive 6p. Once again, the A, and then the B. And then what goes at the end? Always positive, plus b squared, so plus 3 squared is 9. You just take the formula and you fill in the pieces. A minus b, a squared, minus a times b, plus b squared. You just fill that all in. Is it right? You could always check it. 2p, 4p squared gives us 8p to the third. 2 times 6 plus 12p squared. 2 times 9 plus 18p. And remember, this is the key. This is the opposite, right? Minus 3 times 4 gives me minus 12p squared. Minus 3 times 6 gives us minus 18p. And minus 3 times positive 9 minus 27. Everything in the middle, so that I'm left with 8p squared minus 27. Try one more time. Okay? What is our A? What times itself 3 times makes 27? 3. What times itself 3 times makes m cubed? M. What times itself 3 times makes 343? If you don't know, you might have to check. Is it 5 cubed? 5 cubed is 125. Is it 6 cubed? 6 cubed is 216. Is it 7 cubed? 7 cubed is 343. Then our B will be 7 and an n. So how do I do this now? This one is a squared, or a cubed, sorry, plus b cubed. I have that notes above, so that it'll be a plus b, a squared minus ab plus b squared. What is a times b? What is 3 times 7? Oh no, we're not there yet. A plus b. Sorry, we're all excited. A plus b would be 3m plus 7n. What would a squared be? 3m times 3m, 9m squared, minus a times b, 3 times 7, 21 mn, plus b squared, 7n times 7n, 49 n squared. And that's it. Type it in, hit enter, get your credit. You can always check it. 27 m to the third, 3 times 21 minus 63 m squared n, plus 3 times 49 would be 120 plus 27, 147. M n squared. Do the same thing here. 7 times 9. How about plus 63 m squared n minus 147 mn squared. And last, 7 times 49 plus 343 n to the third. Everything in the middle zeroes out, it works. Okay? So keep it up. We've got one more big section on factoring, and then we'll do some applications. I promise you, this is such an important skill, and we are going to be building on this, so make sure you get comfortable through these sections.